Okay, so welcome to Math 349 Operations of Order. This is the first time I've taught a class like this officially. I've taught independent studies like this in the past, and I'm very excited to finally be offering a class like this. So the intersection of this class and the description in the web will be greater than 0, but it will not be 100%. I want to adjust the course a little bit based on who's in it. When we have a nice upper level class like this, it's not going to be a one-size-fits-all. And so I want to get to know everybody. I want to get a sense of what do you want to get out of this course, both for your time at Williams and beyond. And we have lots of different choices of what material to look at. So I've written, I think, 6 books and over 200 papers so far. I know I've got that somewhere later in the slides. And depending on what you're interested in, there's lots of different ways we can go. So I thought, today I would talk a little bit about, course mechanics, talk a little bit about what some of the options are, and then maybe end a little bit early and just, try to get a chance to chat with you all a little bit. First week is going to be a little bit hectic. And so just, high level, what do I want us to get out of this? I want us to gain some expertise in technical or expository writing. And, to some extent, you can even go further to this and also include, giving talks and presentations. We are the only department on campus to still require students to give some kind of public talk to graduate. Is there anybody here who is considering being a professional mime? I won't make you speak up because I know that would be rude if that's what you're thinking of doing. So no one is thinking of being a mime. Excellent. No, I'm not excellent. I mean, of course, there's nothing wrong with a career in mime, but this means you're going to have to communicate with people. I was fascinated a few days ago when my daughter had to look something up, and she made a remark that, she's almost never had to look at a textbook in her life. Everything she gets is through video or through people lecturing. And she would rather download or watch a 7-minute YouTube video than just quickly skim through a file. My generation absolutely give me the text document to look at. So one of the things that I am absolutely open to for this class is exploring what do we mean by mathematical writing? What is a textbook? We have thousands of years with almost no change in the technology of how information is transferred, and then where things are now is extremely different than when I was a kid. Out of curiosity, how many people know what the word QWERTY means? Okay, what is QWERTY?
It's the top line.
It's the top line of the keyboard, QWERTY. And why does a keyboard begin that way?
That's how typewriters used to be, so you couldn't type so fast.
Yes, it was designed to slow people down. If you hit 2 keys that were close to each other on the typewriter in quick succession, they would jam as they went to hit the paper. So to slow people down, they designed typewriters like this. There is no need to have a typewriter like this in the 21st century, or to have a keyboard like this in the 21st century. Why do we do this?
It's convention.
It's convention, but if we cared about you, if we loved you, wouldn't we make the change? Possibly, but we'd have to make the change. We'd have to do the work. And you have all the people who have learned how to type on the old keyboards. And so there's tremendous inertia. And so for a lot of things, it's worth stopping and thinking, why are we doing things the way we're doing? It makes no sense in the 21st century to have a QWERTY keyboard, other than the fact that the people who are in the leadership positions are people who grew up with the QWERTY keyboards. And what are you going to do when you go out? Do you want to learn a new keyboard? No. When I was teaching at Princeton years ago, I asked the students in multi at the end of a year, how many of you liked the problems of a cylinder intersects a cylinder at right angles, and you have to find the volume of the intersection? Nobody liked those problems. I said, okay, should we remove those problems from the curriculum? Oh, absolutely not. Well, why not? Well, we had to suffer through them. So we want the next group of students. And then for extra credit, I said, whoever can get closest to how many years I've now asked this question and gotten the same response. So I'm very open in this class to thinking about what do we mean by mathematical writing? It doesn't necessarily have to be just standard text anymore. If people are interested in preparing videos and online resources, absolutely. I do a lot of math outreach and math lectures. After today, after teaching complex, I am going to then be going to the elementary school in Lanesboro and doing math with them. And so there's lots of opportunities of taking math outreach and writing up articles for publication, as well as having videos on that as well. So in terms of expertise in technical and expository writing, I'm happy to view writing in a very general sense as to maybe more communication would be a better word to put there than writing. Hello. Math 349?
Yes.
Excellent. Welcome. And then everything is being recorded, so whatever you missed, you can just watch later today. Okay, so I want you to see some applications of earlier courses. So hopefully everybody here has taken multivariable calculus and linear algebra. You might have taken either real analysis or abstract algebra. I've actually never taken abstract algebra. I've taught it and I will teach it again in the spring. One of the challenges, especially when you're starting your mathematical career, is everybody is coming from different backgrounds, from different schools where you provide different explanations of how you do things. And so frequently there are small little gaps in your mathematical backgrounds, not a big deal. Happy to fill those in as needed. But part of it is I want you to see, why have you learned some of this material? What can we do with it? And a lot of times, the stuff that you learn is never really used. I remember my freshman physics class was a monster of a course. And about 2/3 of the way through, the professor who became my mentor said, everything we've done up to now is just glorified high school Mickey Mouse physics, and our jaws dropped because as freshmen, we had done general relativity in tensor form. We're going, what is beyond what we've been doing? Oh, okay, now we're going to do relativistic electrodynamics. Okay. He really threw things at us. He said, look, almost everything you learn in the standard introduction to physics, I've never used in my professional career. And there's a huge difference between the math we teach you, and depending on what you do post-Williams, what is the math that you're actually going to use? I'm not even going to ask, is there anybody here who has not done a web search? I'm going to assume at this point, everybody has done a web search. I am old enough that I can tell you precisely where I was when somebody told me you have to see this new search engine called Google that had just come out as a new site to look up information. The content is no longer as important as it used to be. And by that, I mean, you don't have to know things because information is very readily accessible. When I was learning calculus, a big topic was how to convert integrals to a form that you would find in a table of integrals. How many of you have looked at a table of integrals or had to learn how to use them? Not that many. And so nowadays you can put something into Mathematica or Wolfram Alpha or a bunch of other sites, and it will evaluate the integral for you. And just in the background, it will just churn through and it will do the calculations and it will then tell you, here's what the integral is. Well, in the old days, things, pages cost money. And so you would not write down every possible formulation because there's just too many possible formulations. And so you had to learn, how do I convert what I know, what I have, to something that I know or something that's written down. So in terms of what have you done in the earlier classes that's going to matter, a lot of it is problem solving, problem formulation. How do you ask a good question? How do you start attacking it? What are good perspectives? But the actual content from a lot of the classes, some of the more fundamental stuff, working with sequences and series, that's going to be very important. But most of the facts, these are things that you can just quickly look up now as needed. And so I really want to emphasize in this class the more high-level thinking about how do we attack problems. I want to prepare you basically for grad school or industry. Those are the two big areas where people typically go to. And as much as possible, you want to try to get data on which choice do you think is going to be right for you. It's very difficult. You can't really go to graduate school for 3 or 4 years and then put it on hold, go to industry for 3 or 4 years, and then make a choice. You have summers where you have opportunities to try to get a sense of what would a career in industry look like, what would a career in research look like. Anything I can do to help you in terms of getting that information, let me know. Do I have any graduating seniors? Okay, so you know that you have at least a 5th, if not a 6th class in terms of applying for jobs or graduate school. Okay, unless you already have something. If you're fortunate enough to already have something, then you're in good shape. If you don't, it's a tremendous amount of work. And so either if you are applying for things or just if you have a conflict coming up, as long as you let me know at least 24 hours in advance, I'm happy to move deadlines and whatnot. If anybody wants to do practice interviews, anything like that, I'm happy to do stuff like that as well. But for a course like this, if there's particular content that you're interested in, that can give you something that you can then talk about in job interviews, or can help prepare you if you're trying to do a summer research experience for undergraduate program, stuff like that. All right. The other thing is I really want you to gain an appreciation for what is it like to write. How many people have ever listened to a comedian? So my son likes to watch a lot of comedians on YouTube. So I might actually have some non-trivial intersection with the comedians you like. I like a lot of the old classics. One of my favorites is George Carlin. I love his choice of words, at least when he's not being super profane, and his facial expressions and whatnot. It is extremely different to give a lecture than to write something down. When you give a lecture, you're giving a lecture to a specific set of people that you know that you can see. And as the semester progresses and you get to know them, you get a better sense of what might they like to hear. When you are writing something down, it's got to be totally ordered on the page axis. You've got to choose your presentation. You've got to choose how you're going to explain everything, what you're going to explain, in what order. You can have flow charts and say, you can do it this way, you can do it that way, but there's a finite number of things that you have to, for the most part, specify beforehand. It's very different than giving a lecture where you can all of a sudden get some input and say, oh, people are not understanding this as much as I thought. One of my favorite examples is my first year at Williams. I was teaching differential equations. And this is so long ago that not everybody had a phone, or what you would consider a phone today. And so we had clickers where you could actually answer questions, and I could quickly get a sense of how many in the class pressed 1, how many pressed 2, how many pressed 3. And differential equations did not require linear algebra as a prerequisite, but I wanted to talk about systems of equations, predator-prey models. And so I wanted to just do a little bit with 2x2 matrices. And so I asked the class, is anybody uncomfortable with 2x2 matrices? Does anybody want a review of 2x2 matrices? Silence. So everybody's fine with 2x2 matrices. Okay, I'm not going to report back to the class, but I'm just curious. Press 1 if you want to review, press 2 if you don't. I will not lie, but I will mislead. I never said I wouldn't tell other classes. I just said I wouldn't tell them what the answer was. 43% wanted a review of 2x2 matrices. 0% were willing to raise their hand and say, I'd like a review of 2x2 matrices. So one of the things that's real challenge is you're trying to figure out how much information do you provide. When you are giving a live lecture, you actually often have the ability to ask questions and get a sense of what are people's background. You can find out who they are either in class or beforehand and get a sense of what you need to do. When you're writing a book, you don't have that option. What you can do is you can have links to supplemental resources, you can have appendices, but it is a real challenge when you're writing to determine exactly what level should you go, what resources should you provide. Years ago, I taught an independent study on mathematical writing, and it was not writing, it did not count as a writing intensive class, and there was no writing credit for it. And I remember the very first class, we spent 50 minutes on just one sentence. Now, the next class was great. We actually got through 2 sentences and then got exponentially better after that. But just really talking about what do you want to do, what work is each word doing? Okay. Types of problems. So when I proposed the class, the main thing that I was thinking of is interchanging order of operations. So I have an interesting family. All of my uncles have degrees in engineering. She's technically my first cousin once removed, but she's really more like almost a second mother to me. She has a degree in physics. And so she and I have had a very special relationship with all the engineers around us. And so with her physics degree and my physics and math background, we have a very different perspective on mathematics than all the engineers in the family who know a lot of math, but they use it very differently. They often play a lot more fast and loose with the mathematics than we do. And so a lot of times people are not so good at remembering to include conditions of theorems. So does anybody know what 1 plus a half plus a fourth plus an eighth plus a 16th plus a 32nd ... equals? Yes,
I believe it goes to 1.
almost. 1 plus a half plus a fourth. I'm starting at 1, so it doesn't go to 1. It goes to, it would go to 2. And one way to think about this is I start at 1, and then I move 1/2. So that's half the distance from 1 to 2. I then move 1/4, which is half the distance from 1.5 to 2. I then move 1/8, which is half the distance from 1 3/4 to 2. What is 1 plus 2 plus 4 plus 8 plus 16 plus 32 and so on? Infinity, or it's -1. And so the reason we got 1 plus a half plus a fourth is we use the geometric series formula. The sum of the geometric series is 1 over 1 minus r. Well, if you want to use the geometric series formula, what must be true about r? So does everybody remember the geometric series formula? Okay. I'm just thinking about what's the best way to do this. So let's see. They've updated Zoom and they have all these different things now. I just want a white screen. Okay. I don't. All right. Normally I do things on the iPad. Okay. All right, here we go. Okay. 1 plus r squared plus r cubed plus ... equals 1 over 1 minus r. Does this look familiar now? So this is the geometric series. There's a lot of ways to prove this. One way is let's let S of n be 1 plus r plus ... plus r to the n. Then r times S of n. Well, what 1 times r is r times r is r squared. And then the last thing we would have would be r to the n plus 1. And so I'm just multiplying every term by r. So when I subtract, you see that everything cancels except for the first and the last term. So you get 1 minus r times Sn, just factoring out the Sn on the left-hand side, is equal to 1 minus r to the n plus 1. So S of n is 1 divided by 1 minus r to the n plus 1 over 1 minus r. I've just divided both sides by 1 minus r. And the reason I'm writing it like this is because if I now send n to infinity, what does the second term go to? So what does r to the n plus 1 over 1 minus r go to? Why infinity? Okay. But you have to provide more justification. So why does that mean r to the n plus 1 over 1 minus r goes to infinity? So whenever you have a theorem, you have to give me conditions. What's true about r? Yes. I haven't said anything about r. Right now, I just wrote something down. When I look at the finite sum, r can be anything I want. Any number is going to be fine. At this point, there might be one thing you might be a little bit worried about. What's the, yes? If r is equal to 1, I might be a little bit worried about this. If you're not worried, there's a lot of openings in physics classes. I would suggest you go there. If you're in a math class, you should be worried about dividing by 0, right? So if r equals 1, I really should not be doing this. Can you tell me what values of r would have r to the n plus 1 over 1 minus r behaving nice as n goes to infinity? Yes. So if I take r equals 10, would that behave nicely? So let's think about what happens. So if r is fixed, the denominator stays the same. What happens to 10 to the n plus 1 as n goes to infinity? So you'd have 10, 10 squared, 10 cubed, 10 to the 4th, 10 to the 5th. It gets very large very fast. Well, I haven't said anything about r. So if r equals 10, then this term is going to go to infinity. There's not going to be a nice limit, right? So for what values of r will this actually go to something nice? So 1 is between 0 and 1, but more values of r would work. So I'm looking at r to the n. If r is between 0 and 1, r to the n plus 1 is definitely going to go to 0. So 1 is between -1 and 1. But you guys are discriminating against an entire set of numbers. And it's the class I'm teaching after this. Complex. If I take a number of absolute value at most 1, I could take a complex number. So as long as the absolute value of r is less than 1, this term goes to 0. So we could say, and as n goes to infinity, the second term goes to 0 if the absolute value of r is less than 1. And so if we take r equals 1/2, we get a sum of 2. And that's just 1 over 1 minus 1/2. It's just going to be 2. What if I take r equals 2? That would give 1 plus 2 plus 4 plus 8 plus ... equals what? I'll put it in quotes, -1 if we use the formula. So if I just use the formula, forgetting about the second piece, it's 1 over 1 minus r. If I put in r equals 2, I get -1. This sum is so large, it goes past positive infinity, starts at negative infinity, and almost makes it back to 0, putting it out -1. Do you think this sum equals -1? No. Now, interestingly, if you know p-adic arithmetic, there is a way to interpret this -1 as, yes, it really does equal -1. That's another story. What went wrong here? What went wrong with saying that this is -1? We went outside the constraint, but cannot, as the absolute value of r is not less than 1. So one of the big issues in mathematics is making sure that when you have a theorem, you know what are the conditions to use it properly. And so a lot of times in your classes, you may have seen some math, but not necessarily seen all the justifications for when can you do things. And so sometimes there's a result that is true most of the time, but if you have a really bad pathological situation, it might be false. And so that was the motivation for the book on interchanging order of operations. There's a lot of things in mathematics that you have to be careful about. So do people remember the Fubini theorem for multivariable calculus? This is the theorem that says if you have a nice rectangle, you can integrate over x and then y, or you can integrate over y and then x. It doesn't matter which order you integrate. It turns out that's not always the case. That there are times when if I give you certain functions, you will get a different order depending on which way you integrate. So out of curiosity, how many people took multivariable at Williams? And how many people did not take multivariable at Williams? Okay. How many people had a class where they were told that there are conditions you have to check for switching order of integration? All right, so 3 people. So not that many. So you've got to be very careful. And so there's a lot of really interesting mathematics that's related to trying to justify when can we do things in any order that we want? Another great area for possibilities is the Fibonacci numbers. So there actually is an international association dedicated to the Fibonacci numbers. I am the president-elect. One of my greatest contributions was, out of curiosity, does everybody here know the Fibonacci numbers? 1, 1, 2, 3, or 0, 1, 1, 2, 3, or 1, 2, 3. Now, of course, by stopping there, I'm being deliberately vague. What comes after 3? 5, then 8, then 13. Each number is the sum of the previous. So when I joined the board, there were 12 members of the Fibonacci Association. And I said, it's ridiculous to have 12 people in the Fibonacci board when we're just one board member away from 13. So let's either make Fibonacci an honorary emeritus member, or better yet, let's just make someone else, a member. What I love about the Fibonacci numbers is they are extremely accessible. There's a lot of wonderful, fun stuff you can do with them. And they require almost no background to get started. But to prove some interesting results often requires good results in probability, in analysis, game theory. And so I have been given an opportunity to write a book on basically a springboard to good mathematics through the Fibonacci numbers. And so if people are interested, I've been working with students for decades on Fibonacci numbers. There's a lot of stuff that's already been done. And there's also some new stuff that can be done if people want to try their hand at some original research. The next Fibonacci conference is going to be summer 2024 in Los Angeles. And depending on what you're doing, it's definitely a possibility to come and present there. After that would be, I think, 2026 in Istanbul. And what I love about the Fibonacci numbers, and I'm going to be doing stuff with them with fourth graders later today, is you can often get into the game very quickly without knowing too much. And so on Monday's lecture, we'll probably do some of those games here to just see how quickly they can arise. In terms of other types of problems, I do a tremendous amount of math outreach, trying to find ways to have interesting mathematics come into the curriculum. Depending on what grade you are dealing with, it's often easier or harder. As you get deep into high school, the curriculum is very fixed. There's a lot of concerns about standardized tests. With younger kids, you often have greater flexibility. There's a couple of other projects I'm thinking of. And again, if there are specific topics that you would like to see as well, always happy to have some input and suggestions. Oops. Okay. All right, so I've talked about all of this. So in terms of just my background, I've done a lot of professional development lectures, and I in fact was talking with somebody earlier this morning about opportunities, who is now the executive director of a big organization. I serve on a regional school committee, so I've had a lot of experience with curriculums. I've also done a lot of consulting, most often with students on problems for finance, for health care, for Major League Baseball. And if people are interested in stuff like this, I'm happy to talk to you about some of my experiences when we have a mechanical malfunction and the recordings somehow stop working for a couple of moments. All right, course mechanics. So yeah, I'm going to be completely honest. This is the first time I've taught this class, so it's a little bit in flux. I am extremely open to input from you in terms of what do you want to get out of this. I really don't want to structure a class where we're doing a lot of homework problems, taking exams and whatnot. To me, I think you have plenty of experience doing homework problems and taking exams. That's not the purpose of this. The purpose of this is to write the homework problems. So part of this course is, if you're doing mathematical writing, to come up with problems. And then what do you do once you have the problems? Solve them. So the question is, can you come up with a good problem? If you want someone to solve a difficult problem, how do you make a difficult problem easier? What can you do? Break it into parts. Part A, part B, part C, and you start guiding people in certain ways. What do you do if you want to make the problem difficult? You put in a, I don't know if people still know this phrase, a red herring. Have you ever heard this phrase? You put in something that's completely unrelated. And then people will focus. In the real world, You're not going to get just the information you need and nothing else. You'll either have too little information or you'll have too much information. You have to decide which things really matter. So one of the things I'm going to want you to do in this class is, as you're doing the mathematical writing, I'm going to want you to write homework problems based on whatever you're doing. And depending on who you're working for, is this for elementary school kids? Is this for graduate students? The homework problems will be very different. If possible, I'd like you to solve the homework problems. And again, for stuff like this, I'm quite happy for people to be working together in groups. And, hopefully there will be a nice distribution of what people's interests are, but if almost everybody's interested in one thing, that's fine. And we can definitely go in that direction. So if I'm in my office, it's office hours. I'm always happy to chat, always up for grabbing a cup of coffee or lunch or taking a walk. I am a New Englander, so basically that means even if it's a hurricane, I don't really care. I was actually driving from Pittsfield in the great storm last night. And so it wasn't until I got home that I saw all the warning messages about how bad things were. But, I think it's the next set of slides. Yeah, this is some advice from my brother. So he has 3 pieces of advice. One is party less than the person next to you. Take advantage of office hours and mentor. Once you get to industry or to graduate school, you are not going to be in the same environment as Williams. People come here because they want to be with great students like you. We want you to come to office hours. We want to get together with you. I'm a little bit different than most professors where I make absolutely no effort to get to know you. Why? It's on you. Because when you leave Williams, it's going to be on you. So I will make myself accessible. But I know this is being recorded. I make no effort to try to get to know you before the semester begins because I want you to get to the point where you make people know you. You should try to get at least one professor to know you well each semester. That way, if you're only successful half the time, you will still graduate with 3 or 4 people who know you well enough that they can sing your praises or that they will be aware of what your interests are so that when opportunities come up, they can pass them your way. Whenever you speak up in class, please send me an email afterwards and put 349 so I know what class this is regarding, and just say, hey, professor, I made the following comment today. If you made a bad comment, that's fine. You can still say I made the following comments that were good. I made the following comments that were not so good. I really just want you to get used to speaking in public. I was terrified when I was an undergraduate and could not speak in public, even if I knew the answer. And what happens is you don't get noticed. There's a great quote, you're 1 in a million, which means there's 1,000 like you in China or India. You want people to know who you are. It is difficult for a lot of us to speak up. I was that way. One of my best friends from graduate school is responsible, I think, as much as my advisor for my development in graduate school. She told me one day in my first year at Princeton, you should run for social chair for the graduate college. It's like, I think you want somebody who likes people to be a social chair. So you'd be good at it. And so there were 3 positions. And so that night at dinner, I did have friends. I said, if one of you will run with me, I'll do it. And it was the best thing that happened to me, is it really kicked me out of my shell and got me more comfortable to speak up. It's not easy. And for some people, it's easier than others. I really want you to try to get comfortable speaking up. So try to make comments in class and then email me afterwards and say, hey, these were the comments I made. And I just want you to get used to speaking. I want you to try to get to know me either individually or in groups. You can have a couple of you say, hey, would you like to grab an ice cream or a coffee? I'm happy to treat. Would you like to go for a walk? The more I know about you, the more likely I can figure out, hey, you would probably be good for the following opportunity. Who has the oldest alumni society in America? Williams. We have a tremendous number of people who are successful and who love this institution and love the students. So one of the best things you have going for you is the network. And the network is not just your current colleagues here and the professors, but it's all of the students that we've had. So if I know you're interested in something, there's a good chance that we have a student who is doing something along those lines that we can set you up with. there's also a lot of very interesting characters who come to campus. So you've either read or you should be reading soon the Batman graduation speech. I was actually able to get him to come to campus a couple of years ago. And we had some students who were interested in a career in film, and to have the person who owns the movie rights to Batman able to talk to them and give them advice is absolutely phenomenal. In an amazing twist, that happened to be exactly when my daughter had a homework assignment, and I think her 3rd grade class, to come up with a superhero. And so I got him to grade my daughter's homework assignment and bring them into the teacher. This is one of the joys of being at a place like Williams. Take advantage of what you have here. When you leave Williams, you're not going to have the active push by people to provide these opportunities. So while you're here, be aware of what's going on. I will often give you course credit or exemption if you go to certain activities, because I think that's that networking is as valuable as anything else. The last point that I really want to drive home is learn how to manage your time. So many people that I've met over the years have been extremely brilliant, but are unable to manage their time and get things done. If all of a sudden you're given a presidential medal and you have to fly to the White House, valid excuse. Family member dies unexpectedly, valid excuse. Most of the time, however, your deadlines are far enough in advance that you can be planning and you should not be surprised. You should plan for some small things to go wrong. That, I thought I was going to have the day beforehand to work on it, and all of a sudden something came up and I'm not going to be able to do it. That's not a valid excuse. You should not be planning to get things done just at the last minute. This is driving the car with the tank on empty as you pull into the gas station. You should be planning to get things done in advance. And so I'll try to have all deadlines, far enough in advance so that it should not be a problem. If there is something that's going to happen or might happen, just let me know, and I'm always happy to adjust deadlines if it's more than 24 hours in advance. If it's less than 24 hours, it's got to be, earth-shattering event to really happen. And I just know too many students who have lost opportunities because they miss deadlines, sometimes by 10 seconds. And, they can't cry to the computer, the portals, it's now after midnight, we're not accepting your application. So I really want you to be aware of these things. And some of the people who were late, it's because something went wrong with the upload or something went wrong with the file conversion, and they didn't leave themselves enough time for things to go wrong. So if possible, I'll add one piece of advice for myself: always have a plan B, and if not, a plan C and a D and an E. Any hockey fans here? Do you know about the hockey emergency goalie rule? So what is the rule?
Each team has a backup, or not backup, but like usually a guy, not from the street, but just a non-hockey player, like played college or whatever, moved to the city, and he's always in the building.
Yes.
In case the 3 goalies get hurt.
Yep. So each team only has a limited number of goalies that they carry. And at each game, there is somebody in the stands so that if a team runs out of goalies, they go into the game. And a couple of years ago, Carolina was playing Toronto, and the Carolina goalie gets injured, backup goalie goes in, and so they alert the guy in the stands. He drives the Zamboni, and he occasionally does practice for Toronto. They tell him, just get ready just in case. And then a few minutes later, he finds himself the oldest person going in to start a game. And it's just, you have to be ready for unexpected situations like this. He quickly let up a few goals, then settled down and won the game. And then I'm married to a professor of marketing. What I love is Carolina was brilliant about this, and they flew him and his family to Carolina for their next game. They honored him. He had a medical issue, and they sold shirts. I bought one where proceeds went to his charity, but they had a plan B. You should always have a plan B in case things don't go well. What else can you do? What's your backup? I think that is all of the general stuff. Yes. So now let me stop this. And so I just want to end with one little bit of math content. And so now, okay. Most days I'm not going to be going between multiple devices, which will make it a little bit easier. Okay. So now I want to share the screen. Okay. And so just so we have a little bit of content, Okay. What I want to do is I want to just briefly mention Fubini's theorem. So when is the integral a to b, I'll do x equals a to b, integral y equals c to d, f of x, y, dy dx equal to the integral y goes from c to d, integral x goes from a to b, f of x, y, dx, dy. And by this, I mean integrating in this order. We first do the y integral, then we do the x, or we first do the x integral, and then we do the y. So this is an extremely useful result. There's really only two things we can do in multivariable calculus for integrals. We can change the order of integration, and we can change variables. A lot of the change of variables are pretty obvious. If I give you an integral on a sphere, what kind of variables do you think you should use? I'm sorry? Well, we're on a sphere. So r and theta is not enough. What do we call the variables we want to use on a sphere? Phi is the third one. We normally do rho theta phi. This is where mathematicians and physicists have different notation. What do we call the variables we use on a sphere? Who remembers what they're called? These are the spherical variables. What variables do we use on a cylinder? Cylindrical, right? Now, it gets hard, on a circle we use polar, not circular. But, in a lot of situations, the change of variable is pretty clear as to what to do. If I'm on a sphere, if I have something that only depends on the distance from the center, then the theta and the phi can often be integrated out, and I often want to do a change of variables like that. So what makes Fubini's theorem great is this is another way of solving problems. And sometimes an integral is very easy one way, but very hard the other. And so the question is this always true? And so I want to give you a quick example. What I'm going to do instead is I'm going to give an example where the sum n goes from 0 to infinity, the sum m goes from 0 to infinity of a m n is not the sum m goes from 0 to infinity, the sum n goes from 0 to infinity of a m n. So I'm going to do it as a double sum rather than a double integral. You can take the double sum and smear it out and make it continuous functions. And so I'm going to define things as follows. And so in the interest of time, I'm only going to draw a finite set of what's going on. And so I'll do maybe two more. So this is the point 0, 0. This is the point 1, 0, 2, 0, and so on. This is the point 0, 1, and so on. And I'm going to define my function to be plus 1 here, minus 1 here, and then 0 for the rest of time going up. Then it's going to be 0, plus 1, minus 1, and then 0 going up. And then 0, 0, plus 1, minus 1, and then 0 going all the way up, and so on, and so on, and so on. Okay, and again, if you don't like this, what you can do is you can draw like a cone. You could draw like a cone centered at this point, in terms of what the function is, and just spread it out so it has a volume of 1 and a radius of, say, 1/2. So if we sum vertically, what do we get? What do you get if you sum any column? 0. So vertical sums are 0. So then if we do the vertical sum first and then horizontal, what do we get? What would we get? So we sum each vertical thing first, And then once we have all the vertical sums, then we sum all of those. So what would we get? Well, each vertical sum was 0. It'd just be 0, right? No, vertical, then horizontal. So we first sum all the verticals. Each vertical gives us 0. And so this would just be 0 plus 0 plus 0 plus 0 is 0. What about the horizontal sums? What's true about the horizontal sums? First one is 1, and then what's everything else? 0. I am. I just, in the interest of time, I just can't draw everything. It would then be 0, 0, 0, plus 1, minus 1, and so on. So the horizontal sums are 1, then 0. So horizontal, then vertical is going to be 1 plus 0 plus 0 plus dot dot dot, and that equals 1. So these are not equal. So this is a quick example of how the order of summation matters. Okay, and so we can't always, switch orders, but we'd like to. And so one of the things that I'm definitely up for exploring this semester is there's a whole slew of things where order matters. And sometimes you can switch, sometimes you can't. All right, this is a good time to stop because I've got to get ready for my next class.